Happy Monday.
Happy Monday. How's it going, Joe?
Good, good. I think we're all jazzed and somewhat tuckered out from the weekend.
Yeah. We gave a Data Science Go bootcamp on data engineering. And so we have lots of thoughts today, even though we talked all yesterday basically about what data engineering is.
Yeah, it's one of those things where I think we're actually probably more stoked to talk about data engineering since we've already been blabbing about it online. So
it's a lot of fun.
Yeah, I think that was a fun boot camp. Shout out to the Data Science Go team for letting us give a boot camp. I think we have our own unique take on data engineering. Glad the attendees liked it, hopefully, and it was a lot of fun. I was also on a panel on Saturday. We talked about leadership in data science. That was also I think a fun diversion, but glad to be back talking about data engineering. So
yeah.
You want to kick off the discussion? What's that?
Oh, I mean, in some sense, the book we're writing is kind of about this idea. I mean, it's not a book about leadership, but it's a book about how data engineering has kind of evolved to be a more abstract field and more business value focused. And leadership is really, really important in the mix.
Yeah, surprisingly enough, it's weird. You can't escape leadership.
Yep.
So, awesome. You want to kick things off today?
Sure. Yeah. So today we want to give our take on what data engineering is. And I think both Joe and I have been involved in the space for a bit and now run a consulting company built around data engineering. And we've seen a lot of evolution even within the last 5 to 10 years. And so that's kind of what this is going to be about today. We'll talk about what we think data engineering is. We're very opinionated about this. We love to get people's questions and pushback and everything else. So if you have questions, definitely throw them into the chat and we'll talk those over.
Yeah, walk me through that. I mean, you kind of mentioned a timeline here. Do you want to kind of walk through the sort of progression of where you see data engineering has been and is going?
Yeah. So in the recent past, even in 2015, 2016, you would read, tech blog posts about how the way to make an amazing salary was to be a Hadoop engineer or a big data engineer, writing MapReduce jobs basically, or at least, managing software that would create MapReduce jobs for you, things like Pig and Hive. And then, of course, cloud was already a big thing by then. EMR was a big thing, Elastic MapReduce, which is Amazon's version of managed Hadoop. But there was just this big cultural shift that happened between 2015 and today, where the focus kind of moved away from managing Hadoop more to managing data more generally. And so that's where, inspired by a lot of different sources, like Google, for example, we came up with this concept of the data engineering lifecycle. So we're not claiming that's really new, but we're claiming that that's what's important now. So in other words, the focus on tools has been reduced. I mean, if you're an engineer, then inherently, yes, you have to focus on technology. You have to focus on design. But the focus now is more on the big problems of not just getting data from A to B, but making it useful. Turns out it's hard to make data useful. You take raw data, and often it's not very useful to data scientists and machine learning engineers. But the focus now is on finding the right tools out of a variety of different tools to make that data useful. And so it's no longer here's a single stack that's going to do everything for you, and you're going to spend your career babysitting that stack. Instead, you'll look at the problems, the business problems, the data problems, the machine learning problems, and figure out what tools in your toolbox will allow you to go from A to B.
Let me show you a couple slides here real quick that might kind of illuminate this. So these are the famous Matt Turk. Matt Turk's a VC. He also does a terrific job at compiling these data landscape. I think they're called Loom Escapes, actually, when you have a bunch of logos and a slide that looks like this. Anyway, this is 2012. This is the 2012 big data landscape. Notice that you can see logos.
Yeah.
Right? And I was around at this time, and even then I was like, wow, there's a lot of tools. Gosh, it couldn't possibly get bigger than this. It seems like there's a lot of things to know about, right? You had your Verticas, and your Parexels, and your Green Plums, and your Teradata, right? I mean, these were the MPP data databases, data warehouses back in the day. Hadoop-related Cloudera, Hortonworks, MapR, and all these other tools, right? And I want you to remember these tools and the date 2012. And think to yourself, how of the logos on this list, how many are people still using today?
Exactly. Yeah.
right?
And it's funny, some tools have become more popular. Like Flink, I think that's been around for about 10 years, but it's become extremely popular. But a lot of these tools have just kind of fallen by the wayside.
I would say most of them
Yeah.
have. And you fast forward to 2020. Um, this is the I would say it's a partial list as well. This isn't even everything, right? And I know there's some new fields in here, but at the same time, the point stands. If you're to look at now, is MPP data where database is still even a thing on here? Exactly the point. A lot of the logos that you'd seen back in the day, here we go. Yeah, I mean, a lot of the ones that we saw aren't even on here anymore. If you go to MPP, for example, and I think the point stands that the number of tools has exploded, the number of options has exploded. The level of abstraction has also played a big role in simplifying the things that people back in these days, right? Like you were using Hadoop, HDFS, very low level stuff. Even these tools, it wasn't a cakewalk to use this stuff back then.
Yep.
So.
Did you ever read Hadoop, The Definitive Guide?
I have, actually.
It was a good book. Yep. I didn't finish the whole, I read sections of it, but I'm just looking at the table of contents right now, because like back in the day, this was kind of it for big data, right? So 2015, so they've got things like Hadoop IO, setting up a Hadoop cluster, Yarn. And then the tool set that they mentioned here is Avro, Parquet, Flume, Scoop, Pig, Hive, let's see, Crunch, Spark. Spark was the new cool thing, HBase, Zookeeper. And then if you think about it, a lot of these tools have fallen by the wayside, and they're just a tiny subset of what you might actually be.
Yeah, machine learning. Check this out. Okay, so back in the day, I remember Mahout. That was like that, and Weka, sklearn had just come out. You didn't have any of the deep learning frameworks yet. Mahout was the big one. Who uses Mahout these days for machine learning?
Exactly.
I'll send you a raffle prize if you can say that you're seriously, that's the only tool you're using in production intentionally. So I mean, the whole point is, things change, right? This is 2012, 2020. You can't possibly know. Okay, look at this. Okay, how it's like one logo here out of like a bajillion. And the thing is, this is only frameworks. This is, a lot of, I would say a lot of these applications also have like AI enabled. A lot of it's probably marketing speak, but you kind of get the point here. So back to the point of abstraction, right? There's a lot to keep track of and a lot of tools. George actually has a question. What's up, George? He's actually going to have a Nerd Herd episode coming out.
Nice.
This week. So good to see you, man. Do you think there will be more hybrid engineers in the future, i.e. software and data engineers? What do you think?
I think there's a lot of truth to this idea. And I want to say that like you probably, to be a good data engineer, you shouldn't just be a general purpose software engineer, right? It's a very focused skill set. But I think software engineering is an important part of it. So is ops and other things, right? Because data engineers tend to, these days, work a lot in a cloud environment, have a lot of cloud ops responsibilities, in addition to responsibilities for software development in that context. I don't know. What do you think, Joe?
Yeah, I mean, I think we've identified software engineering as being one of the undercurrents of data engineering as well, where a good data engineer should, I think, in our opinion, have good software engineering chops, just because it will come up. I think but I think ask the question in reverse though. Will software engineers meld with data engineers?
Yeah, that's a good question. I mean, software engineering itself is really so specialized. So for example, being a front-end engineer is dramatically different from being a back-end engineer, and the day-to-day responsibilities of your job depend a lot on what kind of infrastructure you're working on, what kind of languages, what kind of frameworks. So in data engineering, it's kind of the same thing in some ways. What I would say is that software engineers can definitely move into data engineering with some training. There's that like data intuition they have to develop, in my opinion, because typically as a software engineer these days, if you're dealing with like small services and things, you're used to thinking of data in terms of small chunks of data, like API calls and requests and things. And you have to get that intuition for like scanning, petabytes of data or terabytes of data at once. But otherwise, like software engineers have a lot of overlapping skills with data engineers.
I would say of any skill set, that's probably the easiest one to make the jump into data. You just need to learn data concepts. And I think, but if you're used to dealing with software, that's I think skill-wise, that that's probably the easiest. I would still make an argument that having data intuition, like an analyst or a data scientist, may have an easier role, but I think those are also roles where they're, for better or for worse, notoriously labeled as not being good at programming. So, I mean, that's just a stereotype.
Yeah.
Giselle has a really good point here, actually. Giselle Waters, what's up? I'm no expert, but the problem spaces are requiring hybrid thinking and designing. I tend to agree with this notion. I think it's a good call.
Well, especially where, like you were saying, there's so many different tools. The modern data engineer's responsibility is really to interact with a lot of different tools and SaaS platforms and APIs. And it really is a very hybrid role. It's not, you're not going to be focusing on a single Hadoop stack anymore, generally. If you use Hadoop at all, it's going to be very abstracted behind something like EMR Dataproc, typically, if you're like modern, let's say.
Yeah, it depends where you work.
It depends where
if you're working at some of these companies, I'd say that where that's like sort of the atomic backend infrastructure. Maybe if you're like at maybe a Google or something, where a variation of this still is what you're using. That's cool. Yeah, for the most part, if you're just doing pedestrian work as a data engineer at some company, probably won't matter. Got a question here from Peter. How can I encourage a highly regulated industry to move beyond the 1990s era data engineering? Wow, that's a great question. I feel like we're missing the bus on all of the new value and efficiencies. You want to take this one?
This is a really tricky one. The problem is that because of their kind of legacies, companies in this space tend to be like highly regulated. They tend to be very allergic to the cloud. It's like, if I don't control it, then it's not secure. And somehow you have to get beyond that thinking to saying, okay, these are all the security specifications of the cloud that you're going to use, whether it's AWS, GCP, Oracle, whatever it is. And then these are the legal guarantees, like what legal recourse do you have if someone screws up? And I think the other important thing to realize is that buying a cloud service is not so different from buying software, right? Like if you're buying Oracle for on-prem, you also have certain security expectations of that software that are critical, or routers or networking equipment or whatever it is. And so it's like this big shift in thinking to say a cloud infrastructure platform is really not different from buying software in terms of your ability to control it. If it's proprietary, you can't see inside of it anyway, and you do have to rely on the vendor to some extent.
But remove the cloud from the equation, for example. Yeah. Like if you're in a highly regulated industry, there might be, you might not be able to go to the cloud, right? But you might still be using 1990s era data engineering. I'd like your take on what do you think 90s data engineering is? Is that like, kind of like grunge or, but in all seriousness, I would say the practices, it maybe it's worth showing, it maybe, lunch and learns exposing people to new practices. So I think you can still get away with using open source technologies and leveraging those within your on-prem environment. I'm assuming you can't move away from it because you're highly regulated, because otherwise I think you would have made the move to the cloud by now, unless your leadership is so stubborn that, it just hasn't happened yet. But there are some ways around this, I think, still, right?
Interesting.
Okay, this shed some on-prem Oracle and Informatica. Yeah, I think that's more of a process and more of an enlightenment type of a question, really. You can still probably do what you're going to be doing with Oracle and Informatica, and that's probably it's the old saying, what got you here isn't going to get you there. So I think it's identifying like what are the next level business goals you're trying to achieve. Can Oracle and Informatica get you there? And if it can't, what are some of the more modern options you can use? So.
Well, Spark might be a good tool to adopt in this case, right? You'd want like some kind of like nicely managed Spark that comes with some guarantees that you can run on-prem, and maybe something like Airflow or Daxter or some mature open source that you could run. One of the interesting things, I was just thinking about this question, and banks have actually been pretty progressive in new technology adoption. Like, yes, some of their internal processes are still pretty stodgy, but they've been pretty good about, adopting Spark, adopting cloud, and yet they're some of the most highly regulated institutions in the world. And so I don't know if there are things you can learn from the banking industry. Obviously, banks have deep pockets as well, which is part of the issue here.
But finance is having trouble retaining talent because they're all moving to big tech companies. And I would say maybe an option is if you can't, convince leadership of the need to move to advance your tools, find another job somewhere. There's nothing that gets people's attention like a good brain drain. So when your top talent leaves your company because you're behind the times, that's I think that's a good wake up call for people. So, as a follow up question here, I can't read that, but I'll do your best. Is it possible that cloud providers will divide the areas into domains, and we will have a GCP data engineer, AWS data engineer?
There's some truth to this, although I do feel like you can become highly specialized in GCP or AWS. But I feel like once you have core cloud concepts, probably the best thing to do is to actually go certify in the other cloud that you want to move to, and you can pick up the differences. Like, AWS networking versus GCP networking, there are actually very significant differences. But the core concepts of like regions, zones, networks, subnetworks, VPCs, all that, VPNs, all that stuff is still there in both clouds. You just have to understand how to specialize it to different clouds. I don't know. What are your thoughts on this, Joe? Like, you've worked across both. Yeah.
The Wall Street Journal article, I get the newsletter from Wall Street Journal. I also subscribe anyway. But they had an interesting article today where, in the past, it was all about AWS. Yep. AWS all day, and there's been a shift. Multi-cloud's becoming a real thing now, and so it's Azure, AWS, and then Google, Oracle, even, or nipping at the heels of Azure and AWS, and multi-clouds, increasingly becoming what people are using. So I would say there's maybe two modes to this. You'll have a GCP data engineer and an AWS data engineer. I'd say Matt and I are actually both. Yeah. I would say we're equally competent in either cloud. You can throw us into an AWS or GCP situation, we'll do just fine. We've done certs in their clouds. We've done, pretty much. We've worked in both environments, so we're fairly ambidextrous. And Snowflake, that's the other one we're ambidextrous in. But I think it's a matter of like what are you trying to do at your work, and what would your work allow as well? Like, are they going multi-cloud? If they are, you're probably going to have to level up and make your brain hurt a bit, because you're going to need to know. But that said, there's always going to there's going to be companies that choose single clouds too. And so just get good at a cloud. I think that the skills of like transferring between clouds is a lot easier than I think getting deep in the technologies of one cloud. I think once you get a good mental construct of how a cloud works and how the technologies work, they're pretty similar-ish when you move to different. There's obviously some details. Otherwise, what would be the point of having two clouds? You could just choose one, and that would be it. Yeah. But there's compelling details. But I think if you understand the big picture concepts and probably a bit of the underlying details, you'll make the transition just fine. Like I was studying for the Azure cert, and that was an easy one. I think I never finished it because I got distracted. But understanding how that thing worked was, I think, really, really easy.
Because you'd already done it in other clouds. It's the old thing too. Like, I know a lot of engineers who just want to work on Oracle their entire career, or just Teradata, and it's going to be the same thing. Like, right? Some people are just going to want to do Google BigQuery their entire career. There was one engineer, we were doing a big cloud migration, and they knew on-prem Oracle data warehousing. And when the cloud migration started, they're like, I'm going to go look for another job because I don't want to learn this. And I feel like in terms of interest, in other words, making your career interesting, and in terms of staying fresh, I always want to be learning new stuff and not just stuck in a rut somewhere.
But then again, Muhammad Ali, shout out to the greatest boxer of all time. Just kidding. SQL, Python, and working with data are transferable skills. How it runs itself. Yeah, totally agree with this.
Yeah, agree with that. Yep.
So, thanks for the comment there. If you have any questions, comments, feel free to leave them in the comments. We'll get to them. But yeah, I think so the role is changing, right? Yeah. There's higher levels of abstraction. There's more tools. It's impossible to keep up on everything. So how do you keep up on everything? What would be some tips?
Oh man, there are kind of two different levels of keeping up. So one level is just like being aware of what's out there. So just like reading, even reading like the GCP newsletter, there are various, This Week in AWS, those kinds of things. Staying on top of the ecosystem and just knowing what's going on in these clouds is a really good start. And in the data space more generally. You can listen to the data engineering podcast, for example, and just know what's happening in the space. And then I think you choose a few tools that are interesting in terms of actual deeper study. Like, you cannot master all of these tools at the same time. And certainly not if you're trying to actually do your job. But pick a few things that are interesting and hopefully useful for what you're doing day to day, and then kind of go into those a bit more and go through some walkthroughs and write some code.
I would say too, like pick an area maybe of the data engineering lifecycle that interests you, right? So maybe that's like source systems, maybe that's ingestion, maybe that's storage, transformation, or serving data. But maybe pick one where you want to get really good and focus on that area, and then understand maybe the top tools in that section. I think that's more of where it's going to be going to. You have to be really good at understanding how lifecycle management works.
Mm-hmm.
And there's another dark horse I think that's going to be coming along, which is data management and governance. We kind of hit on this a bit, where things are becoming more enterprisey, but I think this is, there's a lot more tools in the space that are dealing with traditionally boring topics: data quality, monitoring, observability, so data ops, data management, governance, and so forth. I think these are going to be the areas that data engineering is actually migrating toward as you have more abstraction, like pipelines and ingestion. It's pretty much a solved problem, but for most use cases, you can buy Fivetran and be done. You can get Airbyte, plug that in and be done. A lot of this is solved. Connectors is a solved problem. You don't need to write connectors anymore. And that is happening all up and down the stack right now. Yeah. Storing your data, that's a solved problem. You don't need to use HDFS or anything like that. Unless you want to.
Just use object storage, use an off-the-shelf tool, use Snowflake or something, and just be done with it. Yeah, and if you look at VC activity as well, there's so much venture capital activity in the abstraction layer that kind of lives above the individual tools in terms of metadata management, orchestration, like lots and lots of different products getting traction in those spaces.
Well, yeah, Matt and I always joke we should just go start a company. We'll raise a bunch of money.
Right.
Pretty damn easy these days. So maybe we will. But yeah, that's definitely true. What are some other areas where you think things are changing?
Oh, that's a good question. Just broadly, we've kind of already hinted at this, right? But there is the big cloud migration happening now. And there's a lot of debate around this too, right? Was it Andreessen Horowitz that recently released an article?
Yeah, Andreessen Horowitz, yeah.
Yeah, that said basically, if you're a big company, then you probably want to get away from the cloud. And other practitioners are like, no, here are the errors in your reasoning. So there's kind of a lot of back and forth going on in that space.
One of the argument I think was looking at, expenses and basically saying like at a certain point, depending on your use case, cloud is going to cost you more money. And I think that analysis showed there's hundreds of billions of dollars being, spent in the cloud that might not be necessary.
Yeah.
I think there's some validity to that. I mean, the premise of the article was you're dumb not to start in the cloud, but you're also dumb at some point to stay in it, right?
Yeah.
And so I think it's a good trade-off analysis. If you're fortunate to get to the point where you can make that trade-off analysis, like congratulations, you've made it in this world as a company. So and you could definitely recognize probably some cost savings by moving to specialized hardware in your own data center for specific use cases. But then we're also seeing multi-cloud. I think we talked about that earlier, but that's it's a big one. Yeah.
Well, and it's funny, the cloud providers themselves now are getting into the multi-cloud game. Snowflake is not per se a cloud provider, but they've been pushing the multi-cloud concept for a long, long time. In other words, Snowflake product basically runs the same on any cloud, except that you have to get into the details of how to connect to import data, for example. So it's going to be a little bit different between Azure and AWS because S3 and blob storage are a bit different between the two clouds. But the actual Snowflake platform is virtually the same across both clouds. In fact, it's the same console, same interface, just going to be different accounts. And then Google is starting to push into this space, right? Like BigQuery Omni is still beta at this point, but they're pushing this idea of being able to control workloads on AWS and run, BigQuery workloads across different clouds. So I'll be very curious to see how that evolves. And then I think we're going to see a lot of other non-cloud vendors push into the space as well as an overlay layer.
Yeah. I think so. Why would somebody want to go multi-cloud though? I mean, it's still, I still hear, various friends in the industry saying that multi-cloud's a stupid idea and nobody should do it. Then I hear other friends in the industry say this is where everything's going and where you should be going.
Yeah. It remains to be seen because just as there's this debate in on-premise cloud, there's also a big debate about whether it really makes sense to be multi-cloud or not, or whether it's kind of a red herring argument.
We got a question here, more of a statement. Seriously, do they expect the workforce to be multi-platform trained? Depends who you're talking. It depends who they are. But I could see a situation where, this is expected to be.
Or do you just have different specialists inside the same large company? Like if you're a huge bank, do you just have some AWS specialists and some GCP specialists and teams that kind of help to interface between those individuals?
It's probably more likely, actually. To expect that on one person, I would say, is a bit unreal. Just because that's a lot of context switching and a lot of things you have to keep up on. I think we're in a unique spot where we have to do that, so we don't have a choice. by the nature of our business. But I would expect at some point we'll have specialists that just deal with this.
Yeah, and in fact, I even wrote a bit about this. So I recently took an AWS exam, this data analytics specialty certification exam, and I wrote a LinkedIn post about that experience, and I mentioned that if you follow GCP best practices, you would probably fail the AWS exam. Or if you follow AWS best practices, you're going to fail a GCP exam because they're different between different clouds, right? Mm-hmm. And the danger is that if you are multi-cloud, you could make mistakes by like getting confused between, if you're just working quickly, you might forget some detail that's slightly different between clouds, make a security error or something very serious like that. So
she's saying the job descriptions are expecting that.
Interesting. Yeah. Yikes. Huh. But that seems like the same old thing, right? Like every job description for data engineering lists like 20 technologies.
Or data science.
Yeah, and there's no candidate that knows everything. It's ridiculous. I mean, the more important thing for me in hiring a candidate is like, do they have a baseline of software engineering experience plus understanding of data where I can train them in the specifics that I need them to know. So for example, I don't care. It's great if they have a GCP or AWS cert, but I'm more interested to know if they can pass one when it's time. If they can.
And this might be sort of indicating too. I see some job descriptions where it's like you need to have experience in AWS, Azure, or GCP, right? I think they're just expecting you to have like cloud experience, basically.
Yeah.
So that might be interpreted. And again, I don't know what job description you're pointing to, but sometimes I see those. And I read between the lines, like, well, they're probably just looking more for your general cloud experience, maybe in one, not necessarily all the above. I guess being math guys or means a lot of different things.
That's right.
Can mean one or all.
That's interesting. This question just popped up.
Hey, Phil, how's it going? I'm interested in learning more about the current debates. Thanks for the interesting where can I learn more about the multi-cloud debate?
We may have to hunt down some references.
There's a site called Cloud Wars. That would be good to go check out.
Also, just reading about Snowflake and their multi-cloud strategy, and then go read about BigQuery Omni, which we can post that maybe in the chat. Hold on, let's find some references if people are interested.
Go for it. Yeah, but there's a lot. I think, and it's still a very early debate. We don't really have a dog in the fight either way. The thing you do need to watch out for is like egress fees, and we're going to get to this at Arnie's statement here. Where AWS for backend and GCP for analytics seems pretty common scenario. I agree. AWS is a very popular application framework. It's also very popular for data, but we see a lot of people using GCP for data. The issue that we see also is that when you have this situation, unless you're very conscious about your egress fees, which is the amount of money you pay to send data outside of your cloud, this can get kind of expensive. And by kind of, I mean like potentially very expensive if you're not careful. So you have to go into that situation with your eyes open.
You really do. Yeah. And one thing we talk to clients about is that maybe sometimes it's not so important to be multi-cloud day to day. It's more that you need to have an exit strategy. So if you decide at some point that you're kind of done with AWS or GCP, do you have a way to migrate?
Yeah, exactly. I think one thing we talk about in architecture, good data architecture, is make sure you're making reversible decisions as much as possible. Jeff Bezos refers to these as two-way doors. You rarely want to go through a door that's one way because you can't get to the exit. And given how fast things are changing right now, you better be really sure about your technology choices and your architectural choices if you're going to make an irreversible decision. And I would say for you to have that level of knowledge and insight, you would be among like the top probably 100th of a percentile in terms of your awareness of the data ecosystem right now. And they should actually be a VC and not a technologist. So make more money.
There's this comment here about data engineering roles expecting Java and Python rather than informatica and SQL tools. I mostly agree. We have seen, and we actually argue that a lot of data engineers should be using more SQL. So SQL is very important, but Java and Python are kind of baselines, especially with the advent of a lot of orchestration. So orchestration is their software frameworks or systems that control other systems, basically. So especially in the cloud where you have a lot of different tools, you need some way of like controlling what all those tools are doing. Airflow became extremely popular very quickly, and now you have a lot of entrants into that space as well, but they're all based in Python, basically, right? Like Python is just this controller language that can talk to other systems. And if you don't know Python, like you'd better learn it if you want to stay modern as a data engineer.
Yep. Yeah. But I could definitely agree with the rather than informatica, which I'll just say like I'll label that as more legacy tooling.
Yeah.
I think, as an earlier comment had made, or earlier question talking about certain tools, very, like these, the world's moving beyond it, right? And so if you're still using these tools, maybe you have a good reason. I'm not going to judge, but there's arguably just better solutions out there these days that are more flexible, easier to use, cheaper, everything else, right? So, but it's your judgment call and your team's call about whether or not you're going to continue using older tools. If you are, more power to you. I'm sure you found something that works for you. If you're on a team where you're stuck using these tools and you really hate your life, there's a lot of data engineering jobs right now. You can go find them. Just know that I think what we're talking about, keep up with the languages, right? Keep up with the technologies, Java, Python, SQL, first-rate languages for data engineering.
Yeah, in fact, go get some certifications on clouds. Actually, for Data Science Go yesterday, we did a lab on Apache Airflow, which is like kind of the king of the hill for orchestration, all based in Python. We didn't have the students program Python, but we kind of walked through what a basic DAG looks like. I think we're going to turn that into something soon, right? We're planning to do some more workshops, so maybe you can join us and we can kind of introduce you to some of the newer tools. Yeah.
Stay tuned soon. Giselle has a question. Hello, Giselle. When you're looking for a data engineer that understands healthcare data regs, regulations, I'm assuming that's what that means. What is the most important skill or skill set you would look for? Someone that advertises knowledge. And let me just bring up this link sheet.
Yeah.
It's here.
This just came up recently with the client, obviously with a couple of clients. We're obviously not going to say who, but this is a very common question.
Yeah.
Yeah.
Healthcare records. Yeah. What are your thoughts? What do they need to understand about the regulations?
I kind of feel like it's not necessarily the data engineer's job to know all the regulations. I feel like there should be, well, it's going to depend on the size of the company, right? But you do need compliance people who really understand the regulations. And then you need data engineers who can communicate and work with those compliance people and say, okay, this is what we have to comply with. Let's work together to figure out the technical strategy to actually be compliant with those rules, whether it's HIPAA, GDPR, CCPA. I think the UK has their version of privacy rules. There are several different healthcare specific rules in the United States, some to do with minors. And that's where a compliance specialist, even maybe an outside consultant, is going to help you to know what you need to do with your particular data to comply. And then the engineer's job is to make sure that you're technically compliant, that your tools actually do what they're supposed to.
Yeah, I think it's definitely a question of legal need to explain the what, the data engineer need to figure out the how that's going to be implemented.
Yeah.
But the data engineer shouldn't be expected, I don't think, to understand because it's a slippery slope. How much healthcare regulation should a data engineer know if they're expected to know healthcare regulations? Yeah. So, it's the same question I'd ask a lawyer, right? What's your baseline knowledge of this? So, it's a tricky one. I would say my preference is to say, you need to understand that you need to obey the law, but I'm not going to tell you specifically which laws, because then you run into what's the old stat, the average person commits 3 felonies a day or something like that. So,
is that right? Am I committing 3 felonies a day?
Yeah. Go look it up.
Okay. But what I would say too, I think another thing we could add in the business space, we're very good about providing monitoring for our business users, right? That's kind of a big part of a data engineer's job, is to give them reporting and such. And so maybe that would be another piece, where data engineering is basically providing compliance reporting to the responsible compliance person. Says, is the data being deleted? Yeah. But
you should engineer and architect with, I think, compliance in mind, right?
For sure.
It would be utterly reckless to say, well, I'm not going to listen to legal because I got my own ideas of how this should work, right? That person would be fired immediately and should be banished from the industry.
That's right. But often we get questions where it's compliance is a technology question where it really isn't just a technology question. So people will say, is Snowflake HIPAA compliant? Is BigQuery HIPAA compliant? And it's well, yes, but only if you use them correctly.
Correct.
Yeah.
Vladimir has a question. How deep does a data engineer need to know computer science, OS, databases, networks? What do you think?
That's a good question. It depends, a lot of things, right? I would say day-to-day, data engineer may not need to know Linux inside and out, depending on what their responsibilities are, right? They should know how to spin up a virtual machine. But the nice thing with the cloud is that you don't have to be a sysadmin anymore, because you create a machine and then you delete it when you're done with it. Like, you generally don't have a bunch of users on one machine. A machine is spun up to do a job and then it gets spun down. So some about OSs, but you don't have to be a Linux sysadmin expert, for example. DBs, that's a big one. It's going to depend on your job role, but like, you need to know a lot about columnar databases. You may need to know a lot about different transactional database types if you're going to be pulling data from those databases, and you need to understand performance. Networking, I typically say that you need to know about cloud networking if you're in a cloud environment, right? If you're on-prem, then you need to work with your network engineering.
Well, and in hybrid though too, you need to be able to talk to on-prem systems maybe.
That's right.
It depends on your role.
It does.
So it's an entirely open-ended question. But yeah, I would say I would overweight on knowing more than less.
Yeah.
It doesn't hurt you, but knowing computer science, I think, is another question. So like, that's a very big area of study.
It's vast.
It doesn't hurt you to understand how, basic algorithms, big O notation. I would say that only benefits you.
Yeah.
The person who's dangerous is the person who doesn't know these kind of things, and then they find a situation where they probably should have known these things. So
yeah. And a general problem we see in the cloud is that everything is too easy, right? It's too easy to make mistakes in some sense, because you can just turn on a VM, you could turn on networks without properly securing them. So you definitely—
networking is a place where you see people getting screwed up a lot in the cloud.
Yeah, and security, like, you gotta be careful.
Security is a big one. I would say that if you're going to overweight on something, like, that's one area where I'd say, like, learn security, because nothing else matters. If your system's not secure, you can be the best data engineer in the world, and everyone's going to steal your data and or breach it, and you're kind of screwed anyway. So Samuel Garcia, what's up? Good to see you again. Hey guys, is there any advantage to prescribing a certain cloud platform to a company based on the cloud platform's other resources? It's a tricky question to unpack.
It is, yeah, I mean, I would say if you're very machine learning focused, for example, if that's like one of your primary use cases for the cloud, then you probably really want to look at what machine learning tools different clouds provide and decide which ones you like. And that might be a major determinant of your decision. So, yeah. I mean,
it's a tricky one, because if you have multiple stakeholders, say your app devs, and your machine learning devs, and everything else in between, then it's kind of like you probably want to centralize in one place. I know there's also the multi-cloud argument we got into before. Yeah. So there's not a right or wrong answer to this question, unfortunately, or fortunately. If it was that easy, I suppose you wouldn't have to ask the question. So, but yeah, I'd evaluate it just on the use cases universally. The problems we see is when people get stuck in a cloud and they can't get out. Yeah. And they want to, then multi-cloud becomes a thing. But it's a tricky one to answer. So unfortunately, I can't give you like a standard answer because it depends. Yeah. So, a good question. Ashutosh asks, do you think data engineering roles are overlapping with the data scientist? What do you think on this?
We kind of talked about this a bit yesterday, right? So partially it depends on the size of your organization. So we're not a fan of the concept of full stack data scientist, but sometimes it's absolutely necessary. I mean, if you're a really small company, then you just don't have enough people to split out roles. And so in that case, you can have someone who's responsible for data engineering and analytics and data science, and you just make it work the best you can. I would say more generally in bigger companies, maybe it's not so much overlap, but a need for like really efficient communication. Like the roles just need to work together very seamlessly to get the job done effectively.
I mean, we're recovering data scientists. You think there'll be a recovering data engineer?
Yeah. So people move back and forth. It's not just a one-way door.
Yeah. I think there will be overlap though, but at the same time, when you zoom out though, right? Yeah. So look what a data engineer is supposed to do. It's the old cliched stat that a data engineer spends 80% of their time cleaning data, getting data, processing data, doing a bunch of like blue collar work. And it's meant to be kind of a dig at the just sort of the grunt work that data scientists have to do. Mm-hmm. But I can make a strong argument that's actually the work a data engineer is supposed to do. The data scientists should be spending all their time, leveraging the domain expertise, providing insights and awesome models that the business can use and generating business value. They shouldn't have to do the grunt work if everything's working the way it should, right? In our opinion. Yeah.
What I might argue is there's an exploratory phase in data science where you are manually pulling data, and that's where the overlap happens, right? Like you explore it, you find the problems with the data, and then you're like, all right, this is really valuable. Let's productionize this. And then you hand off your work to the data engineer to actually turn it into production. And that's the overlap domain. You've really helped the data engineer by doing the initial legwork, discovering the value, doing some initial cleaning, and then they automate it.
Yeah. But it's a good question. I think that it's going to be a moving target still. I think there's going to be a lot overlap with a lot of roles too, not just data engineers and data scientists, but like we talked about software engineers and data engineers and ML engineers and data scientists and ML engineers. I mean, all these have, I think, implicit overlap anyway. And even data management and data engineering, I think that's on a collision course.
Oh, for sure. Yeah.
Yeah. So it's, I could definitely see, data management and data governance becoming like this, cool, like data management 2.0, 3.0, like sexy job of the 21st century. So it's, what did Phil say here? Agree about the division of labor, line of collaboration between data engineering and data scientists. Yep. Yeah, for sure. It is a division of labor. And I think it's just going to continue, because the thing that I think sort of keeps it moving as a moving target is just a level of abstraction that's occurring in data engineering and data science. This is a moving target. So data science is equally becoming more abstracted, I think. So
I think so. Yeah, and there's a lot of contention around like automated data science and ML platforms. Like some people absolutely hate them, right? They're like, no, you can't. You're going to cause a train wreck if you try to use any of this automation. You have to be a data scientist to do this stuff. I guess my attitude is that like you do need to understand the basics of data science so you can understand core concepts like model drift and overtraining. That's important. But even data science specialists sometimes can benefit from products like Google, is it still called AutoML, whatever it's called now, because they can just like some models, they can just auto train and they can check the results and they can look for basic problems like overtraining and deploy, and then they can go on and work on more interesting problems. Like the role of automation and abstraction is to make your life easier so you can get more work done. Maybe that doesn't make your life easier, but like it's like any tool, right? It makes you more powerful. It makes you actually able to do more with your time.
There's a lot of gatekeepers too, I think. Yeah. A lot of gatekeeping in data science saying, well, I've seen these LinkedIn posts, I think they're absolutely ridiculous actually, where they're like, oh, well, to be a data scientist, you have to do everything by hand, and AutoML is a cheat. And I think, as long as it provides value at the end of the day, like I really don't care what you use. Here's the deal. Nobody else cares either. The business doesn't care if you use AutoML or if you use, handwritten models. I would say, what's the best model? If you can't compete with AutoML, then I guess AutoML wins in that case. But I think these gatekeeping kind of elitist things I see online are just, it's a bit short-sighted, and I think they're kind of stupid arguments. So, that's my opinion.
Yeah, I agree. I mean, I get a little bit exercised about this kind of stuff.
So let's calm down. Let's move to another question here. What is the role of DevOps in the data engineering space?
Yeah, this is a good one. I mean,
there's data ops.
Data ops, yeah.
Right. It's a kind of a buzzword, but data is different than software. Go on.
It is. Well, I would say read the DevOps classics, like read the DevOps handbook and the Phoenix Project and the DevOps manifesto, and understand the concepts, and then read about the idea of applying that to data with the DataOps manifesto, for example.
Mm-hmm. Yeah, our friends over at Data Kitchen, they're doing a great job, I think, with data ops and promoting it. Shout out to Chris Berg and team for, I think, leading the charge in data ops. I come from an operations and supply chain background, and so I think just the notion of DevOps and data ops really rings true to me. Just like reducing error, continuous improvement, which are really the underlying principles of any of these, DevOps or data ops, and the same applies to data. So I think, increasingly we see data ops as an undercurrent of data engineering across the data engineering lifecycle. You escape it at your own peril. You should be automating things, automating your deployments. You should be monitoring and observing data and your processes and your systems. And you should have incident response, right? Incident response. How do you respond when things go wrong? That should be part of your playbook. So I think that DevOps principles apply to data engineering very well. So.
Well, and that's one of the benefits of abstraction, right? If you're not down in the guts of Hadoop installing the latest version of, Java or something like that, then you can think about these bigger problems that probably benefit your company a lot more.
For sure.
Yeah.
Peter asks, curious thoughts on analytics engineering, DBT, et cetera.
You want to take this one? I think we both are.
I think it's a subset of data engineering. I think it's cool. He asked a kind of follow-up question. Is it cutting things up too much? I can make an argument both ways. I think that
depends.
I think it's appropriate. I think analytics engineering is basically the new BI engineering. So I don't see much of a difference between the two. Honestly, I just think it's BI engineering just repackaged for like the modern data stack. But I think it still applies. But when you look at what data engineering does, right, get data from source systems, do something useful with it, and provide it to downstream users. that's what analytics engineering essentially does.
Exactly.
So,
the interesting thing about DBT too, I know Fishtown really pushes the idea that DBT is an analytics engineering tool. I actually think it has much broader applications. There's nothing saying that you can't, if I'm an ML engineer and part of my job is to like just flatten some data so I can do something interesting with it, why not just do that with SQL if you have the right tool at hand to do it at that scale? And then use DBT to do it, right? It could just be part of your pipeline. And then if you need to use Spark later, then great. But like, a lot of these tools actually cut across different parts of data engineering, including analytics engineering, ML, parts of ML engineering, et cetera.
Yep, exactly. Cool. I think there's a good questions. Probably a good place to wrap it up.
Yeah.
Thanks to the audience out there. Great questions, great response. Definitely hit us up on YouTube, subscribe to our channel. We're going to be doing a Let's Talk Data Engineering this Friday. Hopefully Chris Tabb can show up, join us. He's our friend across the pond who's become, I think, a really good person to chat data engineering with. So anyway,
can we take a business trip sometime when the world settles down, maybe in a year? We go visit the UK.
Yeah, I think he's actually coming here to Utah at some point too. So yeah. But yeah, anyway, thanks to the audience. Great questions. We'll see you next Monday for the Monday morning data chat. Also subscribe to our newsletter on ternarydata.com.
Yeah.
We have exclusive content as well as all kinds of fun links and stuff. So check it out. See you next week. Have a good one. Bye.
Take care.